Hello, this is another episode with King Solomon and Picozzi. Bam Picozzi. Today I'm taking you through Kirchoff rules and we are going to be talking about KVL and KCL. Kirchoff got two laws that aid us to simplify electrical circuit in order to get the current and voltage going through some part of the circuit. But he started with the KCL.
The KCL law states that the sum of current entering a node equals the sum of currents leaving a node.
So with the KCL, Kirchhoff said that the algebraic sum of currents entering a node is zero. So that's what Kirchhoff said. So indirectly, what this law is making us to know is a node. What is a node? A node is a point where currents split or come together. So for example, if you have this, you can see that maybe I1 is entering, I2 is entering, I3 is entering, but I4 and I5 are leaving. So from KCL, it is telling us that the algebraic sum of current entering is zero. Some people also state it as current entering a node is equal to current leaving the node. So with that in mind, one can say that let's pick all those currents entering this node A. So I1 is entering plus I2 plus I3. They are the ones entering. So they are the ones entering. Then the ones leaving are I4 and I5. They are the ones leaving. So from the second law I stated, they said current entering the node is equal to current leaving the node. So you can put them together. I1 plus I2 plus I3 is equal to I4 plus I5. If you want to use this one too, you just bring everything here so that it becomes I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. So that it tallies with this law that the algebraic sum of current entering a node is 0. So that's basically what the KCL said. So in a question that you might encounter in your course of medicine or exam is they will draw something like this for you. They will tell you that this is 3, this is 5, this is 2, and this is 2, this is I, and this is 1 ampere, 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 ampere. So the question will ask you to find I. So if you want to find I, how are you going to find this I? First, you must know that we are talking of a node here. And on this node, you can see that this is entering, this is leaving, this is entering. But there should be something happening to this one. So this one too will be leaving. So you introduce small I. And you have to first find the small I before you can get the big I that the question wants you to do. So you will say that current entering, we have 3 plus 5 as the entry point. And this must be equal to current leaving. Entry must be equal to leaving. So current leaving will be I plus 2. So you end up getting 8 minus 2 is equal to I. And our I is going to be 6 ampere. After getting the 6 ampere for the I, Now we can come back to this. On this node, you can see that this is entering, leaving. So over here to entering, so node 2. This is node 2. At node 2, current entry must be equal to leaving. Entry is I plus 2, and leaving is equal to capital I plus 1. So I is 6 plus 2 must be equal to I plus 1. So we are getting 8 minus 1 is equal to I. So 7 ampere is equal to I. So this is what we have. So that's how to go by it when you are given a question like this. So this is all about KCL. So now let's talk about KVL.
The KVL law states that the algebraic sum of voltages in a loop, that's a closed path, equals 0. Alternatively, in a loop, the algebraic sum of the voltage sources equals the algebraic sum of the voltage drops.
The algebraic sum of voltages in a closed loop. So state that the algebraic sum of voltages in a closed loop is 0. So in a closed loop, the algebraic sum of voltages is 0. What does it mean? It means that if you are given a simple circuit like this, and we have here to be R1, R2, R3, V1, V2, and current is coming from this side to be I, the one moving here to be I1, and the one moving here to be I2. This is a closed loop. This is another closed loop. So you pick 2 loops from this diagram. And from the 2 loops, we have this to be our first loop. And please, your arrow indicates whether the voltage is going to be plus or minus, whether the resistance with current is going to be positive or minus. So you have to take note of what I'm coming to do. So if you take the loop and the arrow touches the negative before the positive, then you are going to make the voltage negative. But if it touches positive before negative, it is going to be negative. So that's why you are going to get minus V1 because the arrow touches negative before positive. Then you get plus I R1. Why did I say plus? It is plus because if you look at where this arrow is going, it's in the same direction with the current. So they are in the same direction, so it is going to be positive. If they are in opposite directions, it is going to be minus. And when it touches the negative side first, it is minus. Touches positive side first, positive. So let's keep on with what we are doing. Then if you continue the loop, you see that it is in the same direction. So you get plus I1 R2. And there is no other thing. And from the law, it says that in a closed loop is 0. The algebraic sum is 0. So at the end, you end up getting I R1 plus I1 R2 is equal to V1. And that becomes your equation 1. So that is the KVL that I've done over here. So if you want to really understand this very well, we will use this example to explain the whole thing again. But